Hi students, this is Mrs. Foy, and this is a quick screencast about some of these molar mass and mole conversion problems. So I'm going to do a couple of these and hopefully you'll remember how to do, because some of this is review. So let's take a look first at these equivalences, right? So anytime you have an equivalence, you can make a conversion out of that. So the first one we do is 1 mole is equal to 6.02 times 10 to the 23 particles. That means atoms, molecules, or sometimes if it's an ionic compound, we talk about the particles being formula units. So if it's a metal and a nonmetal, then we talk about that being a formula unit. And then now we have a new one, a new equivalence that 1 mole is equal to the molar mass of some compound. So here's kind of what we call the mole map, all right? And you already know how to go back and forth between moles and the number of particles and the number of particles in a mole, right? You just use your factor labeling skills to get rid of the unit that you don't want on the bottom. But now we're adding a new kind of layer to this mole map, and that is going back and forth from grams. And this is what chemists do all the time. So for the rest of the year, you're going to be doing this a lot, all right? So make sure you pay attention. So you're going to calculate what we call the molar mass, and then that's going to be in grams, and then you can go back and forth to moles. All right. And then if you want to go from particles to mass, you have to go to moles first and then go to grams. If you're in grams and you want to go to particles, then you have to get to moles and then go to the number of particles. So that'll be really important to remember. You'll always have a mole map for you. And so let's go ahead and get started on this. All right. So let's look at number 1. You have this worksheet. I'm going to do this ammonium sulfide. So it says, find the formula mass or molar mass of the following. So ammonium sulfide. So I have to be able to write the formula. So I have to use my nomenclature skills to be able to do that. So I know ammonium is NH4 plus. And sulfide is S-2 because I have my periodic table and I know what the charges are. This is a polyatomic. And so I'm going to do crisscross. I need 2 of these and 1 of these. And so I'm going to write NH4 2S. Does that make sense? So now I need to do my molar mass. So nitrogen, I know, is 14.01 grams, and I have 2 of those times 2. Hydrogen is 1.01 grams times 8, and sulfur is 32.06 grams. This is all from the periodic table, right? That's all from the periodic table. So let's see, 14.01 times 2 is 28.02. That's the contribution of nitrogen. Hydrogen is 8.08 grams and sulfur is 32.06. So I'm going to add all those up. 0.02, whoops, 28.02 plus 8.08 plus 32.06. And remember, I'm going to round to the nearest hundredth of a gram. And so the molar mass, the molar mass is going to be 68.16 grams. All right, so you see how I got that. All right, so now, and remember the solution key, you have the solution key to all these. So I'm just going to show you some of these, but then you can check your own work, right? All right, so now let's try another one. Let's try calculate the number of moles from the following. So the first problem I'm doing gives me atoms of iron. So I have 3.46 times 10 to the 22 atoms of iron, and I'm trying to get to moles. So I'm going to look at my mole map and I see I'm here in particle land and I'm trying to get to moles. So I'm going to use my 6.02 times 10 to the 23 particles in a mole. So 6.02 times 10 to the 23, in this case, atoms in 1 mole. And let's see, do my atoms cancel? Yes, they do. All right. So if you have a fancy calculator and you know how to use the exponents, that's great. What I'm going to do is just subtract 22 minus 10 to the 23. So I get 10 to the minus 1. And then I'm going to say 3.46 divided by 6.02. And that gives me 0.5747, right? So I get 3 sig figs here. And so then I need to move this. I need to make this one bigger to be in scientific notation. If I make this bigger, I have to make this one smaller. And this is moles. And then I'm going to round right here, right? Because I have 3 sig figs. So my answer is 5.75 times 10 to the minus 2 moles of iron. And that's my answer. Okay, that's all review. We've already done that before. We've done that earlier in the fall, and so you should feel confident about that. I don't know why that did not erase. Let's try again. Cool. All right, so now let's try this one. Let's try this next problem right here, this one. So 65.5 grams of aluminum nitride, and I want to know how many moles. So let's look at my mole map. This time, I'm going to start in grams. Look, I'm going to start here in grams, and I'm trying to get to moles. So I'm going to use this part of the mole map, and I have to calculate the molar mass. In order to calculate the molar mass, I have to write the formula. So I know aluminum has a charge of +3 because I look at my periodic table and I know the charges. Nitride has a charge of -3, so +3 -3. So I'm just going to write aluminum nitride. So now I have to calculate the molar mass of aluminum nitride. Aluminum has a molar mass of 26.98. Nitride has a mass of 14.01. So I'm going to add that up, 26.98 plus 14.01. And that gives me a molar mass of 40.99 grams per mole, right? Grams in a mole. And I can just put grams. I don't have to confuse you too much. This just means 40.99 grams is equal to 1 mole. So now if I'm trying to find the number of moles, I'm going to write down what I have, grams. I'm going to write down right here, 65.5 grams, 65.5 grams of aluminum nitride. And here is my molar mass that I just calculated. 1 mole of aluminum nitride weighs 40.99 grams. So 40.99 grams in 1 mole. My grams cancel and I get to moles. So now I'm going to do the math. 65.5 divided by 40.99, and that equals 1.597 something moles. Now I get 3 sig figs, so I'm going to round this guy right here. And so my answer is 1.60 moles of aluminum nitride. Okay? All right, let's try another one. And again, this is, guys, I just cannot tell you how important this is in chemistry. We're going to be doing this all the time in chemistry. So it's really important that you do this work. Even though I have given you access to the answer key, don't just copy the answers. You're not going to learn how to do it. You can't pass chemistry unless you know how to do this, okay? So now let's try this one. This problem says calculate the number of grams for the following. So I want to know how much does 3.46 times 10 to the 28 molecules of lithium fluoride, I want to know how many grams that is. All right, so let's look at my mole map. So what I'm doing here is I am starting off with the number of molecules. So I'm starting here, right? I'm starting here. And I want to know how much it weighs. So I'm trying to get to grams. So look where I'm going to have to go. I'm going to have to go from number of particles to moles. And then from moles, I'm going to have to go to grams. So it's going to be a two-step factor labeling problem. All right, so here we go. Let's see. Lithium fluoride, so lithium is a plus, fluoride is a minus, so the formula is lithium fluoride. I'm going to go ahead and calculate the molar mass because I know I'm going to need that. Lithium, shoot, I did not write that down ahead of time. Let me see if I can find it here. Let's see if I can just find a periodic table. So I should have my handy dandy periodic table right with me, but let's see if I can find, oh shoot, this doesn't have the molar mass. Periodic table. So do you guys keep your periodic table with you, I hope? Let's look at this one. Ah, this is good. So lithium is, lithium is, well, are you kidding me? Oh my gosh, this is so funny. I am seriously, here we go. 6.94, thank you. Oh good, my son's here. Can you find me the mass of fluoride, Brendan? All right. Now I gotta find my, all right. 35, that's, so lithium is 6.9, what, Brendan? Yeah, the molar mass. Fluoride, 6.94, yeah, we just round to the nearest 100. And what was fluoride? Yes, please. What is it? 18.99. Okay, thank you. All right, great. It's a family affair here. All right, so 6.94 plus 18.99. Actually, that's good to show you, hey, if you forget your periodic table, you've got the internet at your fingertips, you can do that. Okay, so this is going to be my molar mass. That's how much 1 mole lithium fluoride weighs. So I need to get to moles first, and then I'm going to get to mass. So here I go. 3.46 times 10 to the 28 molecules. This is technically formula units, but that's okay. I'll go with it. Molecules of lithium fluoride, and I have to use Avogadro's number to convert to moles. So 6.02 times 10 to the 23 atoms in this, or molecules, in 1 mole, okay? So now my molecules cancel, now I'm at moles. So now I'm going to use my molar mass right here, but I need the mass to be on the top, 23 grams in 1 mole of lithium fluoride. So my molecules cancel, my moles cancel, and I get to grams, which is what I want. All right, so again, if you know how to use your fancy calculator with the exponents, that's great. I'm just going to subtract my exponents. 10 to the 28 minus 10 to the 23 is 10 to the 5, because that's just easier for me to do. 3.46 times 25.93 divided by 6.02 is 14.90. Let's see, I get 3 sig figs, so that'll do me good. Grams of lithium fluoride. And I have to put my number in scientific notation, and that's not correct scientific notation, so I'm going to move that over 1 to make that 1.49. And if I make this smaller by a factor of 10, I have to make this larger, right? So this is going to be times 10 to the 6 grams of lithium fluoride. All right, that's my answer for that one. All right, good. And so the last one I'm going to do for you today is calculate the number of atoms from the following. So I have 65 grams of iron 4 oxide. I know I'm going to need the molar mass. I might as well just go ahead and do that right now. But let's just take a look at where we are on the mole map here. So remember, sometimes these conversions are going to be a single unit conversion and sometimes they're going to be a double unit. And you can tell by looking at your units. So I'm starting at grams here. I'm starting at grams and I want to get to the number of particles. So let's look at my mole map. I'm starting at grams. I want to get to number of particles. So do you see that I'm going to need to convert to moles and then convert from moles to number of particles? So I'm going to have a two-step factor labeling problem there, okay? So I need the molar mass. So I did actually write down the molar masses of these two elements. So let's figure out what the formula is. So this is your nomenclature. So iron 4 means the charge on the iron is +4. Oxide, I know, has a charge of -2. So I'm going to do crisscross and then I have to reduce, right? So I'm going to get Fe2O, right? So I need, no, I'm not. I'm going to have Fe, one of those, and 2 of those, okay? So now let's calculate the molar mass. So iron has a mass of 55.85. I have one of those. Oxygen has a mass of 1600 times 2. So 16 times 2 is 32 plus 55.85. And so the molar mass of iron 4 oxide is 87.85 grams per mole. So now I can start doing my problem. I'm going to start with what I'm given and just convert as I go. So 65 grams of iron 4 oxide. I need to get rid of the grams. I'm going to look over here and there's my molar mass. I'm going to put the mass on the bottom so that the grams cancel. Grams in 1 mole of iron 4 oxide. So now look what I can do. I can cancel my grams and now I'm in moles. I want molecules. So I need to do one more conversion. This time I'm going to use Avogadro's number, 6.02 times 10 to the 23. In this case, I'll say molecules, but it's really formula units, but that's okay. All right. My moles cancel and I end up with molecules, which is what I want. So my answer is going to be molecules or FUs of iron 4 oxide. All right. So now I just have to do my math. And again, it's just easy for me. I just have a little cheapy calculator here. I don't have any exponent function. So I'm just going to take my 10 to the 23 and put it right there so I won't forget it. And then I'm going to multiply 65 times 6.02 divided by 87.85. And my answer is 4.45. Let's see, I only have 2 sig figs, times 10 to the 23 molecules of FeO2 or iron 4 oxide. And so I have to round, right? And so that's going to be 4.5 times 10 to the 23 molecules of iron 4 oxide. All right, circle your final answer. It is definitely a good idea to do these problems with your work on a separate sheet of paper. All right, that's really important because you can see there's not really enough room here and you're going to make mistakes. So anyway, I hope that has been helpful and I will see you in class.